Welcome to the 19th lecture. We are studying class A power amplifier, and in this short lecture, we will be solving a numerical problem. Right. So we are given this class A amplifier, class A power amplifier, where we have this RC, the same as RL. We don't have a separate RL. This RC is working as an RL. So, and the remaining part is that RE1 and RE2. RE is divided into two parts, RE1 and RE2. So, this is the given circuit. VCC is given to be 15 volts. So, what we are required to do is to find ICQ and VCQ, the Q point IC, and VCE, the voltage gain, and the power gain. These are the three things that we need to find. So, let's start by finding ICQ and VCEQ first. So, where is my eraser? Okay, let's use this paper. So let's first find VCEQ and ICQ. So to find ICQ, we first need to find this voltage, VB. Right. Since this R2 is much smaller than the beta times RE1 plus RE2. Beta is given to be 100. Therefore, we can assume that the current entering into the base terminal is negligibly small compared to this current that is flowing in this branch. So this current is negligible. So we apply the approximate analysis to find VB is equal to R2 over R1 plus R2 times VCC. The values are given. R2 is 330, R1 is 1K, VCC is 15. So we plug these values in, VB comes out to be 3.72 volts. So this is VB. Right. So, and then VE, of course, VE is the voltage at emitter terminal, this terminal with respect to ground. Since the base emitter drop is 0.7 volts, therefore VE, this voltage, is 0.7 lesser than VB. So VE is VB minus 0.7. So it comes out to be approximately 3 volts. And then, since this VE is the voltage of emitter terminal with respect to ground, this means this is the voltage drop across both emitter resistors RE1 and RE2. And we know that RE2 isn't bypassed for DC, it's bypassed for AC only. So therefore, RE would be VE divided by the two resistors RE1 plus RE2. So we know VE, we know RE1, 8.4 ohms, RE2, 36 ohms. Plugging these values gives us IE equal to 68 milliamperes. So this IE, since IE, we know that IE is IB plus IC. So this IB plus IC. Since IB is negligibly small, therefore we assume is that IE is approximately equal to IC. Therefore, ICQ is approximately equal to the IE we have just completed, 68 milliamperes. right? So we have computed IC. The first part, the first portion of the first part. Then we come to the second portion of the first part, and that is VCEQ. We know that the voltage VC, the voltage of the collector terminal with the spectrum can be written as VC is VCC minus IC times RC. So VCC would be VC would be VCC 15 minus 68 milli times 100 ohms. 100 ohms can also be written as 1K. Right. So this gives us VC. Having completed VC, VCEQ would be VC that we will compute here minus the VE that we have already computed. VC we compute here, VCVE we have computed earlier, gives us VCEQ approximately equal to 5.2 volts. So now we have computed VCEQ and IC. IC is 68 milliamperes, VCEQ is 5.2 volts. What's next is part number 2. Part B of the question. Right. Part B is to find AP. So we have to erase this portion once again. But keep in mind, IP is 68 milliampere. You have to remember this. 68 milliamperes. That we will choose in part B. So part B is to find the voltage gain AB. So let's move on to the part B. We have to find AB, and we know that AB is minus RC in parallel with RL. There is no RL. There is only one resistor RC divided by RE plus the portion of RE that is not bypassed, RE1. We know RC 100 ohms, we know RE1 8.2 ohms, but we do not know small RE. How to compute that? We know from the previous course EDC that small RE is VT 26 millivolts divided by the DC RE. So the DC RE is 68 milliamperes. So plug this value here, 68 milliamperes gives us RE, small RE equal to 0.38 ohms. And then if you plug this value of RE here, AB comes out to be RC, that is 100 ohms, divided by small RE, 0.38 plus RE1, 8 ohm. So I've computed AB for you, it comes out to be 11.65. So AB comes out to be 11.65 is the voltage gain. And then we move on to the last part of the question, and that is the power gain. Power gain. AP. To compute AP, we have already studied the formula to compute AP. C part AP. We know it is AB squared Rn over Rl. We studied this in one of our previous lectures, right? Rn over Rl times AB squared. So we have computed AB. We have to just square it, multiply this with Rn and divide by Rl. So Rl is the same as Rc here. Rl and Rc are the same. So we have to compute Rn first. And once we compute Rn, we are done. Put that here and we compute AB. So what is Rn? That is a recap from EDC. EDC. What is the Rn seen by this source entering by looking into the base terminal of this amplifier? Right, what's that? For AC, this appears as ground. So R1 in parallel with R2 in parallel with beta times this junction resistance, small re, plus this Re. That is not bypassed. And we won't include Re2 because it is bypassed here. So our in is R1 in parallel with R2 in parallel with beta times Re plus R4. So plugging all these values, R1 is equal to 1K, R2 330 ohms, beta is 100, small r is small r. We computed in last part. It was 0.38 ohms. Let me check more, right? It is 0.38 ohms. And RE1, 8.2 ohms. Plug all these values, you get Rn equal to 187 ohms. Approximately 187 ohms. There is one approximation in the value I have computed. You make it around 190 ohms if you don't take those approximations. So finally, we are ready to compute AB. That is AB squared Rn over Rc. AB is 11.65, but I don't find a place. Right, let's select this one. AB is AB squared, 11.65 squared, Rn over 187 over Rc or Rl, which is 100. So solving this gives us an AP approximately 255. So this is power gain for this amplifier. So in our upcoming lectures, we will solve at least one more problem, one more numerical problem from class 8 power amplifiers. Thank you.